Welcome back to the Server Virtualization Jumpstart. We're now starting Module 5, where we are going to look at virtual machine movement and Hyper-V replica. I'm Simon Perriman, Microsoft Technical Evangelist, joined by Corey Hines, President and Lead Architect of Hull Systems. So Corey, virtual machine movement and mobility, what is this? Why is it important?
This is probably one of the coolest things that Hyper-V does. If you think about, the idea of a running operating system, and you think about, well, I want to move a running operating system somewhere else. Well, the first thing that typically comes to mind is, well, okay, you got to shut it down and move something. And with Hyper-V, you don't. You can move anything, anywhere, anytime, without any downtime at all. And that's utterly phenomenal for every scenario known to mankind. A lot of this originates from clustering. Now, the next module is more about clustering, but we're going to be alluding to a lot of things as we work through this. So, as an example, your VM's on a disk, and the disk's running out of space. You need to get the VM to a bigger disk. You don't need to turn it off. You can just move it. Your server's got a hardware issue. You need to get your VM to another server. You just move it. It never has to shut off for anything. And so what this fundamentally means is you get to move the configuration of the VM. You get to move the VHDs of the VM without any downtime. That's where we get this idea of live migration. And whether it's shared live migration, which is within cluster environments, or shared nothing, which is not a technically correct term, but it's a very accurately descriptive term of moving a VM from a host to a host with nothing but an Ethernet cable. And then also moving the storage, which through what's called storage live migration. And then finally, replica, which was introduced with the previous version, has gotten better with this version. So those are the things that this module is going to address. So first of all, when we talk about high availability and redundancy for virtualization, why is it important? Well, I love this because, as a person who owns a hosting company, as soon as here's what I find, and I'm going to say you're guilty of this as well as anybody. As soon as you give your stuff to someone else, downtime becomes, why is it down?
Right, your problem, right?
Exactly. But what the reality is, downtime is impossible. We're dealing with hardware, we're dealing with software, we're dealing with people. Three imperfect things, right? Mm-hmm. Of course, there's going to be downtime. It's a matter of how do you minimize the risk, mitigate it, and how do you respond when downtimes occur. So it's not, it's guaranteed that, it's not a matter of if, it's a matter of when and how badly that you're going to go down. Stuff is going to go down. So, why do we have to take stuff down? Obviously, hardware failure being the single biggest culprit. As soon as you turn on a piece of hardware for the first time, you've started a clock to when it's going to crash. Might be next week, might be next month, might be next year. We had a server, as an example of how, stupid this can be, with 8 SSDs in a RAID 0 can sustain 3 SSD failures before the volume goes offline. Lost 3 disks in 4 hours, about 4 days ago. It wasn't a production server, it was one we're using for some test scenarios. Brand new SSDs, less than 6 months old, right? Who would have thought it? But if you start looking at, these idea of nines of availability, which is how the industry often measures this thing, 99% availability is 3.7 days a year. It's a long time.
Of downtime.
Yeah, it's a long time. 3 nines, 8 hours. 4 nines, 53 minutes. 5 nines, 5.3 minutes of downtime a year. It's very, very difficult to achieve 5 nines of availability because even in the event of an unplanned outage, when something has to fail over and reboot, there's a couple of minutes involved in that. Mm-hmm. So you need a lot of luck, a lot of redundancy, and a lot of planning, and a lot of money spent to get to that level of 5 nines. For most organizations, 3 nines is kind of what they sort of strive for, which is, a couple of hours of outages every quarter or so for, regular preventative maintenance. So that's generally, considered pretty acceptable, I think, as long as it's planned for accordingly. So within Windows Server R2 and Hyper-V, what are the components we have in terms of preventing failure? So first of all, for hardware failure, you cannot prevent hardware failure. You can only have 2 of them and have a standby for when it does happen. But there's some framework within Windows in terms of, being able to hot add memory, hot add hard drives, so that when things happen, you don't have to go down to recover from it. You can just recover from it. Within the physical server, live migration for planned downtime and failover clustering for unplanned downtime. With I/O, NLB and teaming, storage multipath, and SMB multi-channel. So this involves, not the server going down, but a channel going down. And in real terms, this translates into a cable failure or translates into a switch failure. We see an inordinately high failure rate on 10 gig cables. For some reason, they will just, cable will run fine, it will just fail. And it seems to be, we use a lot of 10 gig cable. Much higher failure rate than we see, for example, on traditional 1 gig cables. So, you got to plan for these things. If you're running fiber channel is glass cable. It's got a bend radius before it breaks. And you get, someone who's running cable and they just kind of jam it or something a bit and they kink it, you get a cable failure. So I/O redundancy is really built around, cable and path failures or, potentially switch failures in the middle. Switches don't fail often, but when they do so very spectacularly. Application service failure. So for non-cluster aware applications, there's a feature within Hyper-V called application monitoring, which allows you to monitor services running within an application, determining if they fail, and then possibly either restarting the service or failing to another node. You have guest clustering through iSCSI Fiber Channel or VHDX, and you have guest teaming of SRIO VNICs to ensure that you have maximum uptime. And then finally, for disaster recovery, asynchronous replication with Hyper-V Replica, so off-site, so you can replicate to another server within your data center, off your cluster, or to another data center entirely. And then also synchronous replication of CSV, so you can do replication from storage array to storage array, so that you have an identical mirrored storage array. You're starting to get, the higher up you go in this chain, the more expensive things get. Replicating your CSV volumes, that's another SAN. That's expensive. You're talking in increments of, tens of thousands, not thousands or hundreds of dollars.
Incrementally expensive, except for Hyper-V Replica, of course.
Of course.
Of course.
We have
free in inbox.
We have an ongoing joke, of what things cost in data center dollars. And, a $20,000 server is about 10 data center dollars. Data center dollars worth about $2,000, okay. Which means that's about the minimum you're going to spend on anything in a data center. So, we jokingly use the term data center dollars, just to take the edge off some of the bills. All right, so moving along, a key tenet to all of this is the ability to move virtual machines from location to location, either from host to host or locations within a host. Now, I'm going to do a lot of demos in here to show you kind of what this looks like and how you do it. But here are the basic options: virtual machine migration and storage migration. Quick migration. Quick migration is the ability to move a virtual machine from one host to another within a cluster by first saving it and transferring it. Live migration, which is moving it without taking the virtual machine offline. Now, here's an interesting question that often comes up. Quick migration versus live migration. When is quick migration better than live migration?
Well, what's kind of odd about quick migration is it's often faster, actually. So if you can actually survive application downtime, you need to quickly evacuate a host to patch it, and you are willing to risk that downtime. Yeah. Oftentimes, you would go and use a quick migration rather than wait for everything to be
With live migration, you migrate the VM. While the VM's migrating, the VM's also changing. Mm-hmm. So you've got to now migrate the changes. While you're migrating the changes,
differential changes. It's kind of a recursive algorithm.
And so eventually it gets to a point where you catch up. But certainly there's more data moves at the end of the day. As a result, the migration actually can take a little bit longer. So quick migration is typically the fastest way to evacuate a server. Live migration does so without downtime. You have Hyper-V Replica. Then you also have just import and export as a way of moving a VM. So for storage migration, I'm going to show you an example of this now in a second by actually taking my live running domain controller and storage migrating it to a cluster. Scary, but we'll do it. So we have essentially what's happening here is the virtual machine's receiving, the VHD is receiving reads and writes. It's copied to the new destination while it's still running, receiving reads and writes. The writes are mirrored. Once it's all synchronized, the virtual machine is switched to the new disk. And that's all done on the fly. There's a micromillisecond pause in disk I/O, and it's designed to handle that while it just transfers it to the new disk, and then the old disk is destroyed. And so what that looks like, think of for VMware, storage vMotion is the VMware term. What that looks like is this when we actually go do it. So if I go, let's take
Now, while you switch over, a good sample exam question about storage migration might be, what is a good way to perform maintenance on a disk without causing downtime to a virtual machine? In this case, you could storage live migrate the VHD files off of that disk, do your maintenance, storage live migrate them back once it's healthy.
Exactly. The other scenario that we've seen it used for is when we want to take, take a particular VM and we want to move it to a new SAN enclosure, a faster SAN enclosure, without having to take the VM offline. So in the past, you'd have to shut it down. You have to export it, or export-import it to get it moved. Now you can just say the VHD, you go from this folder to that folder.
And we don't really care what type of storage array or storage interface,
No.
right? You could go move it to SMB, other different types of shared storage, so long as we have connections and access.
So if I look at my domain controller here, this one is, let's remove, I don't know what that file is. Can't do the domain controller. It's actually got a reference to a non-existent file. So let's just do this Win client machine here. So I look at this Win client machine and I go look at the settings of it. You can see it's actually stored in a storage folder up on my Scale.it file server. Now let's say I want to move that to another storage location entirely, right? So let's say I want to take that and move it to off of the Scale.it file server onto the local CSV volume on this cluster node. So if I look at this cluster node I'm running on, I've actually got a CSV volume here, volume 1, and I want to create a new folder in here. I'm going to call this one VM storage, and I want to take it off the file server, because maybe the file server is going down for maintenance or something. I don't know. I want to get it off the file server onto the local CSV of my Hyper-V cluster. So I've got a folder for it. We're just going to take the VM, move. Next, move only the storage. So this bottom part right here. I want to move all the virtual machines data to a single location. Browse to the local folder. Identifies the available space, current location size. Identifies the files and disks it's going to move. Click Finish. And you'll see it actually begin to perform the move. And if you look at the status down here, moving storage, synchronized. This is going to take a little while. It's a fairly big file, and the network connections I've got are only 1 gig. So it's going to take a few minutes to actually conduct the move. So we'll just leave it running in the background. But the point is that this admin VM, this Win client VM, which is right here, is still 100% active and using while the VHDs are being migrated. Massive, massive enhancement for Hyper-V, because it enables all sorts of scenarios, moving from one LUN to another, moving from a file server to a local disk, from a local disk to a file server, from one file server to another file server. All those scenarios all of a sudden become possible when you put this in place.
Now, a lot of people ask me, hey, if you now have the flexibility to move out of clusters and move between 2 standalone hosts, do I really still need clustering anymore? And the answer to that is absolutely. When we're talking about doing a live migration, this is for planned downtime, planned failures. And the reason why is that both hosts need to participate in this handoff as we're copying the information. If you have one of the servers crash, it can't participate in this handoff. And so you have what we call an unplanned failure, where we actually have to take recovery actions. That's where failover clustering comes into play. It detects the service is down and restarts it, or it detects a node is down and restarts it. So even though you now have more flexible live migration, it doesn't mean that clustering is any less important for unplanned failures.
Now, that being said, I have seen people use this as what I call a poor man's cluster.
Poor man's cluster, yep.
Which is 2 hosts and a file server, and I didn't cluster anything, and I want to be able to move them between the 2 hosts. You can do that with shared nothing live migration. You can store the VHDs up here and just move the VMs back and forth. But if the node dies, it doesn't auto-recover.
That's the challenge we have,
Yeah.
yeah. So we definitely want to encourage clustering
absolutely.
nevertheless, yeah.
Poor man's clusters are fun, though. They're only like $2 data center dollars.
Very cheap.
All right, so that's storage live migration is chugging along. Now up to 15%. And the funny thing is this will get to like 30% and then tell me it's done. So I don't know quite why it does that, but that's what it tends to do. The little thing's got to bounce up and down somewhere. So that's the move wizard that we just showed you. Live migration of non-clustered virtual machines. This is the notion of what we called shared nothing live migration. The idea that I can take a VM and I can move it from one Hyper-V host to another. without having any cluster component between the host. So this is done by doing first a storage migration, and then once the storage migration is done, then doing what is essentially a live migration over Ethernet.
But we still expose it as a single operation.
Exactly right. So to show you what this looks like, we're going to come in here, and so it looks like that's finished now. Settings. Take our Win client here. Close that down.
Now, while Cora is working on that, I want to bring up another best practice, a kind of a common problem that we see customers run into, and that's trying to live migrate between two different processor families, such as an Intel to an AMD live migration. And this actually won't work, and this is due to the actual processor architecture, how it builds the memory. It's just done differently on an AMD machine and an Intel machine. So you can't take that run-in memory, copy that running memory across these two different processor families. And that limitation isn't unique to Microsoft, to Hyper-V. That's going to be consistent across any hypervisor that you use here. So generally, what would you do if you want to do a migration between these two different systems? Well, you can't do it with the live running memory. So you would have to shut down that, flush out the in-state memory to disk. Then you can go and actually move that between these different systems.
Absolutely.
But Corey, what happens if I have Intel from 2 years ago and I have Intel from today? How do I do the live migration between the same family but different versions?
In order for that to work, within the properties of the processors, you've got to turn on what's called processor compatibility. So if I just look under the compatibility section, I would check this box. Now you've got to check it on when the VM shut down. But what that does is it limits the feature set the processor exposed to make it more broadly compatible.
And it steps it down, right? We go
Correct.
to the lower level.
Correct. So now you get broad compatibility across multiple different processor sets. So this is something that is a really unless you know you're not going to change CPUs, it's a good thing to always check.
Yep, and it could be something, a very popular exam question. I've actually seen it on some of our older versions of these exams.
Absolutely.
As well.
So now what we're going to do is we're going to take this Windows 8 client and we're going to do a shared nothing live migration down to this server called HV3. So we see that the storage migration is completed. I've now got the disks down on the local CSV volume. So we're going to take that and we're going to move it. So we're going to move the entire VM. So not just the virtual machine storage, this is the top option, moving the entire virtual machine. Name of the destination computer, HV3. Move the virtual machine's data, move the virtual data by selecting where to move the items or only the virtual machine. What this means is the top one essentially moves the entire package. The middle one allows you to specify different folders. So if you want to put the snapshots on one folder and the VHD on another, and then the bottom option moves the virtual machine but leaves the storage in place. So destination folder, click finish. And this will take a little while, but we're going to let it kind of chug along in the background. So you can see if I just kind of click out of this, here the virtual machine is moving, kind of chugging along. And if I look at this guy Win client right here, it's still running. And we're just going to kind of leave this guy running and connected. And what you'll see is that I'm already RDP'd into this VM while the VM's been transmitted to another host entirely. And they're not in a cluster. So pretty powerful stuff. And if I get I think I can actually ping. I don't have ping enabled on the machine. So that's what's going on there in the background. So that's chugging along, 6%. This will take a little while to get over there. Last time I ran this, it took about 15, 20 minutes. So that'll just we'll just let that sort of run in the background while we're working through stuff here. So here's kind of a look at what happens in memory. And so we were alluding to why live migration might be a tad slower than quick migration. This is sort of an illustrated example of what happens in RAM. So why that's the case. So after you've completed the storage migration piece, which is the first piece, you migrate the configuration, which is essentially the XML files, and then also all the contents of memory. And you'll notice that while that migration is happening, there's some changes. The little red dots are happening. They've got to get replicated. So that little extra bit is what takes it a little bit longer.
We're basically tracking the pages in memory that get dirted.
Absolutely.
Do that in a recursive subsequent call.
And then finally, the MAC address is updated. And the final copy operation takes less than a TCP timeout, which is about 25 milliseconds. So at most, you will see maybe a dropped ping or two, but is not enough to cause any application to disconnect. So as far as users and applications are concerned, it never went down. If you're running a ping, you may see a missed ping because the pings are typically less than 1 millisecond, but that's basically it.
Now, at the end of this operation as well, we will actually go and clean up that old Hyper-V host, free up those resources as well. But before we move on to this section, I want to answer a few more questions that we get here. One of them is the best practice around simultaneous live migrations. So in this, the 2012 release, we support multiple simultaneous live migrations, both storage live migrations and network live migrations. We don't actually place any hard limits of the number that you can do. So a lot of people think, well, maybe I'll just put it up to 1,000 and try to do as many as this host can have at the same time. It's actually not recommended. What we really want to encourage people to do is find the sweet spot of how many simultaneous live migrations. And that's going to be dependent on the actual application running inside the VM. Now, the reason why is if you think about what's happening when you do a live migration, you kind of do that initial file copy, and then you have to do that secondary, tertiary copy. Now, the pipe's only so big, so maybe the first live migration, you can do 1 in 1 minute. Maybe with 2, you could do 2 in 2 minutes. But as you start to gradually scale up and you're trying to do, let's say, 20 at once, they're going to go as 20th as slow. Now, since they take 20 times as long, we then have a lot more additional pages on the original VMs on the original hosts that are changing in memory. Those changes then have to be replicated. And again, that's going to take even longer, which means more changes, more replication. So sometimes it's actually not going to be faster. From our internal testing, we found the sweet spot's usually about 4 to 7 VMs simultaneously. But really the biggest thing is what's happening in memory. If you have something like a VDI, a thin client VM, where no one's really doing anything, they're browsing around on a local tool or Internet Explorer, not much memory is changing for that secondary copy. If you've got like a high-end SQL application, a lot of memory is changing. That second copy is going to take a long time. That third copy is going to take a long time too. So that's kind of the balance they're finding that sweet spot.
Yeah, there was a lot of misconception around, serial, parallel, do a bunch at the same time. And the reality is it tends to be quicker if you do them one at a time, just one after the other, just for that reason that it gets to do one task.
Right. Now, Corey, again, before we move on, another couple questions came up. Now, we talked about live migration over RDMA earlier, speeding that up. But we also want to talk about live migration compression. Could you just touch on that a little bit, this enhancement?
Yeah, there's not really a lot to it, per se. It's a matter of being able to compress. It comes at the cost of CPU, but you compress the data so the live migration goes quicker. And it's just a matter of when you're configuring this, and so I believe I can pull this up right in here under the settings of the virtual machine under live migrations. Where we to expand this advanced features, where you can choose both the authentication protocol and performance availability. So for example, you can just do straight TCP/IP, which is the lightest on CPU, but a little more in data, do compression. So there's less data that goes across the network, or you can do it over SMB, which will use RDMA if it's available. So default is compression, but you can adjust this based on what you want. If you know you've got RDMA-enabled network interfaces between everything, you can switch it to SMB, which will attempt to leverage that, which is the fastest possible option.
Cool. Now, final 2 questions I've seen coming, and I get these a lot, are talking about live migrations between different platforms. So first of all, can I live migrate between VMware and to Hyper-V or back? And the answer to that is no. There are actual technical limitations, or even if you're going Intel to Intel, how memory is actually built and managed. So you can't just do a live migration from one to another. Whenever you migrate between these platforms, there will be some downtime. Second question about these cross-platform migrations we get a lot is, can you live migrate up to Azure? Again, the answer to that is no, we can't. There's a few limitations on just basically how memory is managed up in Azure, even though we use the same type of virtual machine in VHD files. Now, Corey, you briefly mentioned earlier, I'm hoping you could just cover this again. What is the process to go and move a VM that I've built for my own data center and make that running up in Azure?
There's a couple of things you have to do with it. There's good documentation on this on Azure's website and their documentation, but it basically boils down to a couple of things. Number one, you've got to make sure the VM meets the requirements for Azure, which is single NIC, DHCP, with RDP enabled. Those are the big things, right? It's got to be VHD format. So if it's VHDX, you convert it to VHD. You upload it, you then create a new VM using that VHD from your library, attach your new virtual machine definition of that VHD, boot it, and then if all goes well, you should be able to RDP straight into it.
Okay.
It doesn't all, you might have to try it a couple of times. If the RDP doesn't work, the only choice you've got is to bring it down, test it, re-upload it again. What I generally recommend to folks is, before you upload it, put it up, take the VHD, put it on a Hyper-V box that's got a DHCP-enabled interface, make a new generic VM and turn it on and see if you can hit it over RDP. And if you can, then you're usually going to be okay.
Great best practice.
So that's because honestly, the uploading bit can be painful. Because you've got a 40 or 50 gig VHD, upload speed being what it is, it may take hours, if not days, to do an upload. Now, I believe Azure's, I thought they announced like a hard drive shipment service now or something.
I don't know about that, but
yeah, we saw an announcement too long ago where you can maybe like ship a hard drive to Azure with your stuff on it, and they'll actually connect it and put it in your subscription for you.
Very nice.
So we'll see what that happens. I hope that was public information. It came to me in an email, so there we go.
We'll see.
All right, so what we're going to do now is take a look at Hyper-V Replica and kind of look at what that's all about. Hyper-V Replica is the ability to take a VM and create a replica copy of it in an offline state on another server, nothing to do with clustering. Okay, and so the idea here is this is a hot standby. Now you might say, well, I can restore from a backup. Well, that's fine, you can, but you've got to go through the time of conducting a restore. This means you can power on this VM, and it's as current as up to 5 seconds ago. So, your cluster goes down, completely dead. You've got a standby copy you can power on over here. We actually use this in our own environment consistently because our infrastructure, our core infrastructure, our management infrastructure runs on Hyper-V clusters. And, our immediate sort of hot, warm standby solution is a single server with replicas of everything. So should this cluster for some reason just die, we can power up all our infrastructure over here and get everything back online relatively quickly. And we use DPM for the SQL databases, so we can bring this up, restore the latest SQL database, and we should be good to go. So for prerequisites, first of all, obviously Windows Server 2012 Hyper-V. This is 2012 supports replica. Hyper-V 2012 R2 supports replica and extended replica. You obviously need sufficient storage and connectivity. You have to enable a couple of Windows firewall rules. Now, I will gripe about the Hyper-V UI guys for a second because when you go in and turn on replica, it pops up a cool little message box that kind of sounds like it's doing it for you. But really what it's doing is saying you should go turn on these firewall rules, and everybody forgets. You forget, I forget. We were just talking about this in the break about how we always forget this. So you got to remind me, and we'll try not to forget this when we do it.
Demo will be good.
And it's either HTTP or HTTPS. And then finally, you can do either CRED SSP if everybody's in the same domain, or you can use certificates. And there are hosting providers that, as an example, will offer Hyper-V Replica Endpoint as a service, and they use certificates for authentication. So here's kind of the components of Hyper-V Replica. You have the replication engine that does all the replication, the change tracking module that records write operations and ensures they get sent over the wire, the network module that handles the authentication, compression, and encryption of the network traffic. In a clustering environment, which we'll look at in the next section, the Hyper-V Replica broker role, and then the management tools, which are basically Hyper-V Manager, PowerShell, and if you're doing the Replica broker, which is used in clustering, the cluster management tools. So that's all fine. Let's go take a look at it. So first of all, I've got two standalone servers here. I've got HV3 and HV4. And what I'm going to do is configure one of these VMs to replicate from HV3 to HV4. We're going to take this guy here, server 2, and configure him to replica to the other server. So the first step I've got to do is actually enable replication. So we go
and that's what on the host?
On the host, yep. Yeah. So under Hyper-V settings, you can do this with a couple of PowerShell commands. Enable as a replica server. We're going to use HTTP with Kerberos because I'm all in the same domain here. And I'm going to say a replica from any authenticated server and put it in C:\replica. And we're just going to hit OK on that. And here's the little message box that can kind of tricks everybody. Make sure you turn the firewall rule on. It's not doing it for you. It's reminding you to do it. So we'll do that in just a second. I'll do the same thing on the other replica server. So open up Hyper-V Manager, and we'll go Hyper-V Settings, Replication Configuration, and we'll just sort of mirror that. Now, if I was a service provider, I might choose certificates and put a certificate in there. Now we're going to go turn on the requisite firewall rules. So for that, we're just going to go wf.msc. We'll be doing this on both servers. Inbound rules. And we kind of scroll down a little bit here. You'll see Hyper-V replica listener. So there's two rules right here. There's an HTTP and an HTTPS listener. We're just going to enable both of those. And we'll do the same thing over here. Now, you don't need to do this in every single server. You can do this using group policy. So, I just think it's fun to enable firewall rules. I don't get out much. So those are turned on. Now, the reason I'm doing it on both, by the way, is because I want to be able to reverse replication. You only need to turn this on the server you're replicating to.
The recipient.
Right.
Okay.
But if I want to, at some point go, let's reverse the direction of replication, I need to make sure that the corresponding rule is in place as well. So we're going to go ahead and right-click this VM and just enable replication. I'm going to hit Next. Replica server is going to be HV4. It's going to go verify it can actually talk to that server, verify that Kerberos is intact, verify the port's open. Choose the VHDs I'm going to replicate. How often do I want to replicate? We're going to do this every 30 seconds. I want to maintain hourly recovery points for 24 hours. So I can choose if I need to fail over to the replica, I can basically choose an hour a particular hour that I want to go back to. We'll send the initial copy over the network. We can do it to a media. If we do it to media, let's say I'm replicating a 400 gig VM to a service provider. I might replicate to a hard drive and say, here, load this. I don't want to send this over the network.
Send it over, yep.
And we'll do it immediately. And you'll see this replica begin in the background. This will take a couple of minutes to complete.
Now, I wanted to touch on the replication frequencies here. In your example, you did 30 seconds, and there's actually 3 different replication options available. So 5 minutes is what we originally came out with our first release, but we had some customers saying, hey, you know what, 5 minutes of potential data loss is too much. I need more frequent replication. So then we provided the option for a 30-second replication. Now, at the same time, we also have some customers that live in kind of remote locations where internet cost is expensive, or they don't want these regular spikes every 5 minutes with network traffic. So we provide a third option as well, replicate every 15 minutes. So keep those 3 values in mind. They're probably going to appear on the exam. 30 seconds, 5 minutes, 15 minutes are your different replication frequencies.
And so you can see this from the screen here right now. The replica's sending. It's 34. You can see kind of chugging along with percentage-wise. So we're going to leave this running in the background. We're going to come back to it in a little while and look at some other elements of it. And so you can see right now the health, the status, it's in progress, everything's normal, and we'll be able to view the health of this once it's all finished and see, is it current, is it up to date, what are the statuses on it. So these settings right here that we're looking at are essentially the configuration settings that I just put in as we created the replica. The additional one on the bottom, which is called failover TCP/IP settings. What if you're replicating to a data center that's got a different physical subnet and you don't, for example, or a different DNS server and you don't have network virtualization in place? Well, one of the neat things you can do when a server is configured for replication is under the network adapters, you can configure failover TCP/IP. Okay? And so what this allows you to do is to put in an alternate TCP/IP configuration that only becomes valid when the replica is started. So let's say you're currently on the 10 subnet, you're replicating to a host that's on the 11 subnet using a different DNS server, different default gateway. When the replica is started, the new IP information is actually injected in the VM so that it can be valid on that network when it boots up. So very important thing, if you, again, talking about scenarios where, you conduct a replica, you boot the VM, but you can't ping it. Why not? Different subnet, you didn't do the replica TCP/IP configuration. In terms of checking and verifying replication health, it will be normal if less than 20% of the replication cycles are missed. If more than 20% are missed, or you've missed the last hour, or there's no reverse replication, or something's believed to have gone wrong, it goes to a warning state. And if it's not replicating, it goes to a critical state. So it's very easy to identify if everything is healthy or not. Also, notice that, normal, isn't 100% replica all the time. There's an acceptable level of failure within replica, or it's still considered good.
And I mean, what could be an example of why it cannot do this replication?
If you're in a WAN scenario, a saturated link, or a link went down, or something of that nature.
So it could be a good way to kind of troubleshoot best practice
Yeah.
here. Definitely look at the network as kind of your primary thing with replication.
Absolutely. So there's two ways you can do failover. There's test failover and planned failover. With a test failover, it's non-disruptive. It just verifies that it can do the failover. It doesn't actually take anything offline. The planned failover will perform a number of steps. It will, first of all, requires the source virtual machine be powered off. Okay, so you got to shut down the source virtual machine. You go to the replica site, you do a planned failover, it powers on that virtual machine, injects the network information, and then reverses the direction of replication automatically. So any changes you hear automatically go back to the original. So it completely flips the direction of replication around. That's what a planned failover does. A failover is an unplanned failover where the source, the original VM, is not available, and that simply brings the VM online, injects the new IP information, but it doesn't reverse replication because it assumes that one's gone, and it doesn't power off or do anything with that other VM because it assumes it's gone. So you would only then reverse the replication manually once the original site's recovered, get everything synced up again, then maybe do a planned failover to get it back. And you can see there's some other available actions: pause, view, extend, things of that nature. Let's go take a quick look back and see if replication's finished. It is. So we can go into replication, and we can see where we can do planned failover. We can view the health, which we can see when the last replication was, the amount of data that's moved back and forth, the average latency, how many errors, and then we've done 4 replication cycles already because we're doing them every 15 seconds. Or sorry, every 5 seconds. And then I want to make one little adjustment over here, because I didn't actually, this is the brand new server we installed earlier today. I just need to make my external network adapter. Make sure I get on the right interface here.
Now, while Curry does configure that, I do want to kind of quickly talk about the 2 different types of replication options and the biggest limitation around Hyper-V Replica. Now, generally, when you're thinking about storage replication, you have what's called synchronous or asynchronous replication. With synchronous replication, which is what Hyper-V Replica does not use, we actually make sure that transactions are committed at both sites before they're committed. And so basically at site 1, you'll perform an action, you'll write to the VM, it will send the copy of those changes to site 2, but then it has to wait for an acknowledgement to come back to site 1 saying, hey, this process is complete, the replication has happened, and you have 2 sides in sync. Now, the advantage of that is you don't lose any data. There's 0 data loss with this solution because it's not committed until both sides see the same data. The downside of this is performance, because as you're making a transaction on site 1, you need to send the acknowledgement to the second site, wait for it to come back before it's committed. And so this can actually limit the distance between your different sites. Now, asynchronous replication, which is what Hyper-V Replica use, has the benefit that there's no distance limitations. Everything happens on the first site, gets pushed over to the second site at these regular intervals. The downside of this, of course, though, is you could potentially lose data. If you're replicating, let's say, every 15 minutes, you have a crash 10 minutes after the last replication, there is some possible data loss. So kind of, consider that in mind as you are looking at this. But don't forget, it's free, it's an inbox solution.
Absolutely.
And people say, hey, this only replicates VMs. Don't forget, you can put anything you want inside that VM. So as long as you're running in a fully virtualized environment, you can go replicate other components in your data center.
Absolutely.
Now, we should still be cautious about replicating things like domain controllers, SQL databases, because similar to the checkpoints in the snapshot conversation, you still need to think about synchronization if you're restoring something from a state that could be 15 minutes old.
I have a company I know that uses this for offsite replica of data files.
Okay.
They just throw them all in a VM and they replicate it to an offsite location.
Perfect.
And it just takes care of it for them. They're just using the VM as a container for data. So this is I'm gonna do a little planned failover here. So we're just going to shut down this VM, which is the first requirement for a planned failover. So get this guy shut down. It'll take just a couple of seconds. In theory, anyway. There we go. He's turned off. So now we go to HV4 and we go, all right, let's go ahead and do a planned failover. So go failover. Here's the latest recovery point. And you see the VM has now been booted. Replication directions are going to be reversed. And we are up and running on the replica. So I look at my replication. I can now choose to reverse the replication, and we're essentially good to go. So let's do that. I'm going to go through the wizard. At this point, we're just really clicking next because it's going to remember all the settings. And we're done. So that's how you fail over to the replica copy. So that was a planned failover I did there. And you can see it's sending the replica back and getting everything synced up again. So that's how you do it. It's very simple, very straightforward, very easy to do. All right, so that pretty much takes us up to our clustering module.
That's right. So we're going to take a quick break. We'll be back in 10 minutes, and then we'll be starting our final module of the day, implementing failover clustering with Hyper-V.